Perspective Class 5 Video 1. In this video we're going to talk about coordinates in 3 dimensions. So in previous classes we've been talking about coordinates and vectors in 2 dimensions, and what we're going to do in this class is just try and generalize everything we've been saying about 2 dimensions up to 3 dimensions. So let's begin with the definition of what I mean by coordinates in 3 dimensions. So just like in the plane where you can represent every point with 2 coordinates x and y, an ordered triple, so now I have 3 letters x, y and z. They represent a point in 3-dimensional space, and I need 3 letters because I have 3 directions now. I have the x direction, the y direction and the z direction. Okay, so you should think about it as this is a generalization of what we were doing before. Before we were only considering like the xy plane, so this bit, this flat bit down here. But now we've added literally a whole new dimension. We've added the z dimension to that setup. One thing I want to say which is very important is when I'm talking about 3-dimensional space, there's a convention on how to label the axes. Like when you talk about 2 dimensions, you always put x on the horizontal and y on the vertical. If you've got x, y coordinates, this is just what you do. In 3 dimensions, this is what I want the convention to be. Okay? Because there is actually more than one way of labeling the coordinates, right? I could have labeled this y and this x. And although that's okay, I want to stay consistent and I want to always use this method. So this is the method which I want to use in 3-dimensional space. So let's see an example of a point in 3-dimensional space. So if we look at this example right here, this example says, consider the cuboid in 3-dimensional space that is resting on the xy plane with one vertex at the origin and the other vertex farthest from the origin being 2, 3, 4. What are the coordinates of the other 6 vertices? Okay, so all I'm saying is one vertex is at the origin down there, the other vertex, this one here, is at the coordinate 2, 3, 4. And I want to work out the coordinates of the other remaining corners, the remaining vertices. Okay, so this is the picture for 3 dimensions, and as you can see, it's harder than in 2 dimensions. The analogous picture in 2 dimensions would be something like xy ... like this. So much easier in 2 dimensions. In 3 dimensions, you end up with a cuboid as opposed to like a square. So let's see if we can answer this question. This point here has the coordinates 2, 3, 4, and what this means is I went along the x axis 2, I went along the y axis 3, and I went up the z axis 4. Okay, and it gets a bit confusing because I could have done this in any order. So I could have gone up the z axis, across the y axis, and then along the x axis. Or I could have done up, then x, then I'm not very good at drawing, then y. It doesn't matter which order you do them in, you always end up at the same point. Okay, so let's work out some of these other corners. Let's do some easy ones first. This one down here, well, it's lying on the x-axis. Okay, so this means the x-coordinate is 2, and the y-coordinate, how far is this point in this direction? Well, it's 0. And how high is this point? What's the z-coordinate? That's also 0. Another easy one would be this one up here. This one up here, it's on the z-axis. So that means the x-coordinate is 0, the y-coordinate is 0, and in this case the z-coordinate is 4. The next easiest one would be this one here. It's always easiest to do the ones on the axes first, okay? Because since this one's on the y-axis, that means the x-coordinate is 0, the y-coordinate in this case is 3, and the z-coordinate is 0. Now I have to do some harder ones. So let's think about this one right here. This one here, it's on the XY plane. It's on the z equals 0 plane. So this one here has x coordinate 2, y coordinate 3, and it's 0 z coordinate, 0 height. This one right here has 0 y coordinate. So it has x coordinate equal to 2, y coordinate equal to 0, and z coordinate equal to 4. And finally, this one right here, this one's on the x equals 0 subplane. So this has x equals 0, y equal 3, and z equal 4. Okay, so that's it. I've labeled the other corners of this cuboid. Okay, this is how coordinates in three-dimensional space work. They're directly analogous to coordinates in two-dimensional space. It's just harder to draw pictures of what's going on. Okay, that's the end of this example, and that's the end of this video.